So another screen share opportunity is to pull up the command line when you're talking about traceroute, or tracert is the command. So what we're talking about here, of course, is traceroute, which allows us to basically trace the route that a packet takes when it's sent from one computer to another. And we can actually trace the route of routers, so we can look at the path that the packet's taking across different routers from when it's going from its source to its destination. Now each one of the routers is called a hop, and you can use this to troubleshoot. You can kind of figure out if there's any issues with a specific router. So we can actually run the command here, which on Windows is traceroute, and let's just try to go to espn.com and we'll see what happens. So what's happening is the command is trying to make 3 attempts to contact the router at each hop, and it's going to display the response time for each of these commands. Then it's going to display the DNS name of the router, if it has it, and the router's IP address. So it's probably going to time out relatively soon, so you can talk about that once you see the asterisk, what that actually means. And also if you run it multiple times and you see the same asterisk at the same router, then that can help you troubleshoot an issue. But what's interesting here, if you want to get into it, is talk about how traceroute actually works and talk about a TTL packet, right? A time to live packet. So that basically the TTL value is going to help indicate how many routers a packet can travel through basically its way to its destination. So again, that's how traceroute works, because every time a router forwards an IP packet, it's going to subtract 1 from the packet's TTL value. So when the TTL value reaches 0, the router basically can't or refuses to forward the packet. So traceroute command works by sending ICMP echo request to the destination computer. And when it sends it for the first time, it's going to set the TTL value of the packet to 1. So what does that mean? It's only going to basically one router, and then it can't forward anymore because the TTL value is 0. So it's going to send it back with a time exceeded message back to the original host. And then when the traceroute receives this time exceeded message, it's going to extract the IP address of the router from it, calculate the time it took for the message to return, and it's going to actually display that first hop. Then when it's sending it more on its path, it sets the TTL value to 2. So you get to the first router, and then you get to the second router, and then it's at 0, and it's going to send it back with a time exceeded, again, pull the information that it needs, and then finally, again, keeps setting that TTL value plus 1 to kind of help trace the route and pull the IPs of the router. Okay, so pretty cool. Just some stuff to show and talk about when you do traceroute.